Now we shall discuss about inrush current in transformer. Actually, what happens whenever a power transformer is just switched on without connecting load with its secondary? The primary of that transformer draws a high peaky current from source which is transient in nature. This means there is an inrush of current at the instant of switching on a power transformer. This current is referred as inrush current. Since the duration of this current is up to few milliseconds, inrush current generally does not create any permanent fault in transformer. But inrush current can cause unwanted tripping of circuit breaker of transformer at the time of charging the transformer. Let's have a look at the basic theory of inrush current in transformer. Not only in transformer, in all the devices where magnetic core is used, the phenomena of inrush current may happen. When a transformer is just switched on, the sinusoidal voltage appears across the primary windings. The flux induced in the core is proportional to the magnetizing current and is in quadrature with the applied voltage during steady-state conditions. That means the flux wave will reach its maximum 1/4 cycle after voltage wave reaching its maximum. That again means at the instant of switching on the transformer, if the supply voltage starts from 0, the corresponding steady-state value of flux should be at negative maximum. This is clearly impossible as there is no flux linked to the core prior to switch on, if we think there is no reminiscence before the switch on. The steady-state value of flux cannot be instantly accommodated, as this would imply an infinite rate of energy transfer. Therefore, the steady-state value of flux can only be reached after a finite time determined by the rate at which the circuit can accept energy. Here in this case, like voltage wave, the flux will also start from 0, not from its negative maximum. Now, as per Faraday's law, rate of change of flux with respect to time is directly proportional to induced voltage. So, flux is integral of voltage wave. From this statement, we can say that the value of flux at the end of first half cycle of voltage wave is covered by first half cycle of voltage waveform, and this is integral of Vm sin omega t from 0 to pi. If the maximum value of steady-state flux is phi m, then after integration, we get that the value of flux at the end of first half cycle of voltage wave is 2 into phi m. The core of the transformer are so made that they become saturated just above the maximum value of steady-state flux is reached. Here we have seen the value of flux at the end of first half cycle of voltage wave has jumped to double of its maximum steady-state value. As the core becomes saturated just above phi m, the magnetizing current required to produce rest of the flux above phi m is much higher. This high current will be drawn from primary supply. In other words, there will be an inrush of current in the transformer. This current is transient in nature, may exist only at the time of switching on the transformer. After a finite time, normally in range of milliseconds, the inrush wave is damped out and magnetizing current of transformer gets its steady state value. Thank you.